All right, have you ever really stopped to think about how a machine, like an AI, actually learns to see? It's not magic, and we're about to pull back the curtain on how it understands our visual world. Let's dive in.
So it all kicks off with this simple little mystery. Take a look at this. It's a handwritten number, right? Kind of sloppy, maybe a little rushed. Now, you and we know it is in a split second. But how on earth does a computer, a machine that only understands pure logic, figure out this scribble? Well, the secret to solving this whole thing is realizing it's not some kind of digital magic. See, to a computer, this image isn't a drawing like we think of it. Nope, it's something way, way simpler. It's just data. It's just numbers. Yeah, you heard that right. For an AI, every single image is just a grid. In this case, we're looking at a 28 by 28 grid. Think of it like a tiny piece of graph paper with that number drawn right on top of it. And each of those little squares in the grid has a name. It's called a pixel. That's short for picture element, by the way. It's the absolute smallest dot in a digital image, and every single one holds just one piece of information, how bright it is. So how does it store that brightness? Well, you can see it right here. It's just a number. For a simple black and white image, a value of 0 means pure black. 255 is pure white. And, you guessed it, everything in between is just a different shade of gray. And this really gets to the core of the difference. When we look at that 28 by 28 grid, our brains just see a number. But the computer, it sees a long, long list of 784 numbers, one for every single pixel's brightness. And that's it. That's all the computer has to work with. Okay, so that naturally leads to the next big question, right? How does an AI learn anything from what looks like a random list of 784 numbers? How does it possibly wade through all that data to find a pattern that screams, hey, this is the number 9? Here's the thing. It doesn't. The AI is actually smart enough not to try and understand the whole number at once. That would be way too complicated. Instead, it breaks the problem down. It learns to look for much smaller, much simpler clues inside the image. It actually builds up its understanding in layers, kind of like a hierarchy. It starts at the bottom with the raw data, the pixels. Then it figures out how to combine those pixels to find simple things like edges. After that, it learns to combine those edges to find more complex patterns. And then finally, it pieces all those patterns together to figure out the whole digit. You know, think about it like this. What really makes the number 9? I mean, fundamentally, it's basically a loop on top of a straight vertical line. And an 8? Well, that's just a loop on top of another loop. The AI learns to spot these basic, reusable building blocks first. So how does the AI actually assemble all these little clues? This is where something called a neural network comes into play. And a really great way to think about it is like an assembly line, where every station has a very specific job to do. So at the start of our assembly line, you've got the input layer. Its only job is to take in all the raw pixel data. Then you have the hidden layers in the middle, and this is where the magic really happens. These layers are all about finding edges and then combining them into patterns like the loops and lines we talked about. And then right at the end of the line, the output layer looks at everything that's been assembled, weighs all the evidence, and makes the final guess. And just so you can appreciate the scale of this, the input layer, the very first step, has to process all 784 of those pixel values from that one tiny image, all at the same time. That is a ton of raw material getting fed into our assembly line. So back to the assembly line. The very first hidden layers are looking for super simple stuff. A little horizontal edge here, a diagonal one there. Then the next layers down the line take those simple edges and start combining them into more complex patterns. Yeah, you got it, like our loops and lines. And then finally, you get to the end. The foreman of the operation, the output layer, takes a look at the finished components. It sees a completed loop and a completed vertical line passed down to it. It weighs all that evidence and makes a call. Based on the thousands of examples I've seen before, this combination of a loop and a line, yep, that's most likely a 9. Okay, so that's how an AI learns to read a handwritten number. It's pretty cool, right? But you might be wondering, why does this one little trick matter so much? Why is this a big deal beyond, just sorting the mail? Because this exact same principle, breaking an image into pixels, finding edges, combining them into patterns, this is the engine that powers so much of the modern world. It's how a self-driving car can tell the difference between a stop sign and a speed limit sign. It's how AI helps a doctor spot the incredibly subtle patterns of a disease in a medical scan. It is, without a doubt, fundamentally changing how our entire world works. You know, this quote really nails it. This stuff isn't science fiction anymore. AI is not the future, it's already here. This technology, which all started with a seemingly simple problem of reading a handwritten number, is transforming entire industries as we speak. And all of this leaves us with one last, really fascinating question to think about. We started this whole journey with a simple number. But if an AI can learn to see the patterns that make up a digit, what else can it learn to see? What are the limits? And what other, much more complex patterns in our world is it just on the verge of understanding?